everyone, welcome to the Academy. Today's unit number 4, D and F block elements. So today we are going to learn more details about the transition elements and inner transition elements that you have already learned about it in the previous class 9 and 10. Okay, so here in the class 11 you have already learned about the classifications of the periodic elements and their periodicities. And now in this unit, you are going to specifically learn more particularly about this D and F block elements. Okay, so here in this class, you are going to learn more details about what are the D block elements and what are the F block elements. F block elements have na karino, D block have na karam basbu chingani have a gising. Pulap na details ta koina sigi chapters ta khangani ko. So from this chapter, akoina transition elements hai basi kari marangino. Kana transition elements kogani F block elements haina to khaina nai nai basina karigino makoi sigi characters sing makoi chemical properties as well as physical properties kari no hai basin bugi matang da koina kupna nai nai. So here let's go through their magi syllabus talk ka habitan topics sing kai lakani have do yumina se. So here Sigi unit sa ako'y natanggal na basing doon kasi yari sa habitin yung sa general o na kung lang sa introduction na malani ko. So here we will be learning about the introduction and electronic configuration. Always time we have to learn about the introduction ki part today. Always time yari ni ko. Introduction ki part yari ni electronic configuration. Whenever we learn about the elements, element ang mahay karagadi. Whenever we study the periodic table, we never matam the atomic number, atomic mass, and atomic nalakla. Like aduna, sige chapter sa so when we study about D and F block elements, ani sinay na po matam na kanala kaniba electronic configuration, haba po sila kaniba. Electronic configuration haba de kaniba it is the arrangement or the distribution of the electrons in their orbits. Yari ko. At ang magi orbit niya may gani hana ko na class 9 and 10 di matang dito kay hana hay K cell, N cell, M cell han hay da 2n square ko sige 2n square haba po sinamaram oraga ko na magi number of maximum number of electrons kamana distribute taw gani haba khangi ja angi so sumaine taw duna sige formula se seasonal residity we will be doing or writing the electronic configuration as the principles we have already studied it in class 11. Class 11, the study to give karamba of the principle have to go of the principle. Sige principle, sige matang tanibo ko na ninyo disi. Yari ko. So here we are going to study electronic configuration according to the principle of the principle. And then occurrence and characteristic. Whenever we say the elements, element na mahabi matanda mo kasi kamay ni pangni ko. Or di mo na pangbra, combined form compound, di mo na pangbra, oxide o na pangbra, sulfide o na pangbra, habi sige matang doon is the lapis na. And their characteristic hai. When we say characteristic, both amase ko na nino matanda we have already studied about metals, non-metals, metalloids, ninagrabani chumiko. Metals is hard or ni, non-metal is soft or ni. So, may tamgidra. Chap manana, we are going to study about the D and F block elements. F block or D block elements study the umatam so kay laktiba. Their characteristic karo so study the kaniba. Yari ko. Then we are going to study about the general trends in properties of the first row transition series or transition metals. Abdi Kung na the block elements study ta umatanda na, there may be few transition series like ani ba? Have the first row, second row, third row, ano tunga lakan ni ko. At kung na mainly study ta goder ba trends eh, have the periodicity o gira, mag ionic size ki o metallic character, negativity, electronegativity, electropositivity mo may ang character niya may na ba siya. Kanada lakto ba? We are going to study mainly about kana See, first row transition elements have a first row transition elements have a So here, ako na first row transition elements study tayo matanggal consider tayo siya metallic character. Metallic character, ionization enthalpy, oxidation state, ionic radii or atomic radii, siguma singse, plus color, catalytic properties, magnetic properties, interstitial compounds, and alloy formation. yareko singai sinamage periodic trends. For example, when we study about the elements ama hekta study to matamda kai haige mamanga atomic size, ionic size kamai tawni. Moving from left to right, atomic size decreases, ionic size decreases, inertia and enthalpy increases. Kain tam gid ranga kana cha manabuduni sila laktusi. Yareko. And again, si loigra matunda the main important part ama yore is siki part color have jagas. Yareko. Transition elements kuding magse color show to we han haiba. Adubo exception kara lakani. Some of the few transition ki elements ki block to the diyawa. Adubo transition elements in nati have a kangu kara. Moidi color show to gudra. No, they will not show the color. Duguma singi matang the kara exception lakani ko. Yan catalytic properties. Kay guma reaction ama thokum matanda catalyst on act of yaba. Ki act of bung hamdaba. Tungan recha. Ado transition elements kuding magse kay dubung haba. Mukhoy simse catalyst on act of bungami kana no habuduna sigista kamdu. Catalytic properties have jagas. And what about the magnetic properties? Magnetic properties have mainly two magnetic property. Paramagnetic and diamagnetic. In class 11, you have already studied about the magnetic properties. Ferromagnetic, ferrimagnetic, paramagnetic, diamagnetic, antiferromagnetic. Only two. Ani katanya ba khana doisi yare ko sida khana doise in this magnetic properties you are going to study about the parahaba diahaba paramagnetic diamagnetic only ani se katanya ba yare ko it will be based on the number of the electrons unpaired electrons yabudugi matung ina khana gani and then interstitial compounds akhone interstitial hai taragadi kaino port ani lere ko natraga port khana question lemta marak ta ahu macha khara yawuni dana space macha du da karigum atopa elements kara apchalaga anubu compound form to targadi that is known as the interstitial compounds. So this is known as the interstitial compounds. Kanal interstitial compounds form to this D blocks in D block elements in interstitial compounds form to we are going to study here. Okay. Now here, alloy formation high. What is meant by alloy then? Alloy alloy means those things which is made by the combination of metal and non-metal, and non-metal. So here, see the alloy formation, how much the one will be metal or any here brass high. For example, just we are making an example, taking an example as the brass. So brass it is an alloy of zinc and copper. Zinc and copper ani sige alloy ni haba. Yari ko. So maya tawduna alloy atopo makhal namamlay iron gisu alloy namamlay na cha. So maya moina alloy formation tawangami kamaina ngamino kaygingamino priagati sa diha. Okay. Now here, preparation and the properties in alloy. Preparation and the properties of kanakana. Mainly, we are going to study about the potassium dichromate and potassium permanganate. Potassium permanganate and potassium dichromate high river compound makhal anise. They are the compounds of D block elements. Have the potassium, chromium, and oxygen. Oxygen have some of the oxide near Bukwa. And the Mukogi properties kim the preparation combined the way properties kaino Mukogi reaction. Kadakalaita tobi oxidizing property chain, reducing property chain, oxidation mind to halika. And now we come here, lanthanides. Here, lanthanides have actinides have or lanthanoids and actinoids have any sepunchal laga kanasim deba. F block elements have this hagatoneba. You might have seen in the periodic table that there are two lines in the bottom of the periodic table. Periodic table gi pula biang pumatanda makhada line ani lecha. That is mathaki line do adujuna kana deba F block. Makhagi line duna kana mataki line to na lanthanoid so ini have a makhagi line to na actinoid so ini have garani ko ade tadi sida ko study to this kanano lanthanoids ki electronic configuration similar to this actinoids ki study to gani ko then jab manana oxidation state as well as in the D block it is to high oxidation state yaoge ko jab manana tab gani do then chemical reactivity high di water reaction thodi ke domi acid reaction thogana ke dorakani base ka thogidi kamai tawba habidu matang ni na diba and then lanthanoid contraction size increase decrease hydra on moving from left to right. Atomic size decreases. Atomic size decrease uduna maram oiraga lanthanide contraction to aleba. Sigi lanthanide contraction se kaidamakta tho ino kamai tho alino sigi maramla mass thopasina maram oiraga kari tholai result ta kari phangi. That is the consequences. Yareko. Sigi matang na inagani chamana na lengthenide contraction tho ibagu actinide su contraction tho iko aduna actinide contraction tho pusuga hinaraga lanthanides amasung lanthanoids amasung actinoids ani sigi marata comparison lakani mabani se kadai da manarino kadai da khenarino habadu gi matang yareko. So these are all details about this chapter. So now let's go through the general introduction da amuna inarasi. So this is the general introduction. General introduction के part से मुन्ना हापितन ये मुन्ना सिको. D block elements constitute from group number category. Group number 3 to 12. Group number 3 देखिना 12 hours वो कोई ना करी है ना खाना गनी हाबो मतंदा. It is known as the D block elements है ना खाना गनी. And then it contains 4f and 5 orbitals. Kanano F block elements high target 4f and 5f orbitals. sige 4f high वो पहुंचे बुनी. Sorry, lanthanoids side of lanthanoids, and then this will be known as the actinoids. Yeah, so here Sidagi ko nakagi sa kayo F block and D block habang matanda D block will be from kanaday kanabaw. Group number 3 dagi na group number 12 hawa. Aduga F block hay taragadi predictable gi makada separate wani yauriba anido row anido ko adu odo niya ba. That means kana 4f and 5f jagado ko. Sige orbital ani si yam ko niya ba. Ano 4f series hargadi lanthanoids 5f series hargadi actinoids odo niya ba. And then next, the F block elements is present in the center of the periodic table. Yareko. So the hiding is seeing si ko hapetang. Akoy na periodic table ang manay na rehay si ko. Let's say this is a periodic table. So finally, periodic table ni nakana si mahang hakin ni ko. Just an example, si periodic table ni nalaw taragadi. Si the hydrogen lady nalaw rasi. Let's say here is hydrogen. Si the hydrogen lady ba? Hydrogen lady this one will be the group 1. 1 lady, 2 lady. Now here, see group 3 si the gina group number 12 power si the na eh. Yara ba? Si group number 3 the gina 12 power la eh ko 12. So 12 power sila kung matab sila sige whole body se 3 the gina 12 power se. This will be known as what? The block elements. Yari ko. Kay hay diba? Group number 3 the gina group number 12 power sila the block elements ni haba. Then sidagi group number 13 the gina 18 object sila will be known as the P block elements. Yari ko, P block. Now, makada labor ani sini haba F block elements hay si ko. This is F block. F block sida kay haba mathak to lay series sina. This one will be the 4F. Ko, makada lay sina kay haba sina 5F. Kentare ko, 5F ka 4F ka ani lagi ni. 5F nataba sige 4F sina lanthanoids. Si 5F sina actinoids. Yari ko. So minor group number 1 ga 2 was mala ije kasi na S block na kang nagani ha. Yara ja. Ado ite from this figure you come to know that side se block tunga khaido thangani middle gi center da leribo jaga sibu na D block elements hagani som da lerisina P block nakan da lerisina S block al makha lerisina F block nagani ko. F block the series ani legani 4F series lanthanoids 5F series actinoids na tunga legani ha. Yara ja. Okay, now again sida hu yeng si ko da D block sida yeng ha ba center da lerin hai ba ko center da legani and in the of the periodic table ki center da leni ko ugre ko. Now here transition element have a command defined when have matanda as the one which has incompletely filled d orbital. Yare ko d orbital in its ground state or kana any of its oxidation state hai. First of all, howji ki figure da amtang yengisi ko. Sidana S block, D block, P block, and F block hai se kai ni have male. Sumiyo ko. So the S block hai mugango se magi outermost electronic configuration then there will be the presence of only this S orbital. S orbital yang mani ba. Outermost ni ko hai se valence electron lay ba jaga do the orbital of the valence electron will be S block. S block diba. P block is top manana the outermost electron will be entering here. P da. P orbital ko cham manana D block isu D da leram ma thengna gani F kisu F da leram ma thengna gani ko C F sila. And now I want to add one more thing here. Ngasai gi S haba matam sida ne ko S haba matam da only 2 electrons will enter. Maximum ni ko kaigumba S orbital aramaga di electron masing se kya odeni ba 2 maximum da. Again, if I say it is p orbital then electron masing se kya odu ba it will be 6 maximum the 6 leni ba kaigino S orbital have matam da it consists of only one orbital ko cell ama khatane ba ya ise and then p orbital have a candidate it consists of 3. That means cell ama da electron ani ni chang ya ni na 3 cell le di kya chang ani taru chang ani ba yai ko chang manana for D also D orbital have matam da mangale ni ba mangale rumina it will consist of how many electrons maximum da 10 electrons chang ani na cha then F orbital gi have matam se da do magi tarit legani ba 1 2 3 4 5 6 7 7 le rumina kya la ani magi so 14 electrons le be have chances le have ko so let me write here S block hairagadi kya lagani ba S electron se maximum will be 2 electron because it has only one orbital. Yare ko P block have kanda kanaya diba P electron se masing kya suni ba it will be 6 maximum electrons legani kaya obagi magina orbital masing ahum obagi yare ko. And then what about the D block? The block have matam se dasu the electrons ki masing se maximum will be 10 because it consists of 5 subcell. Yare ko. Then F block ki su kai haba F electrons le jagani F electrons se kya su do ba 14 electrons. Yare ko 14 electrons se da kya lagte ba magi su 1 2 3 4 5 6 1 2 3 4 5 6 7 yare ko 7 orbitals taken have. And you might have already seen in the off-group principle the su uramani ko off-group principle da combine hai gi koina hana tamba matanda 1s 2s 2p 3s 3p 3d 4s 4p 4d 4f then 5s 5p 5d 5f sumali ko next makhada kitang kalakisi ko 6d bawala si 7s 7p 7d sumali iris. Now here electron ahan mo jang kadab se kanadun hai 1s ta adui matung da 2s next 2p la amatung da 3s lani 3p gi matung da 4s jump taraga chatte ko 3d da chakhi deba. Now here 4s ki matung da 3d da lakani ko 3d da laga 4p then 5s matang 4d matang sumai lakani ha yani ko sumai lakwa sina maram oraga sita 3d ha matam sita how many electrons maximum level are 10 ha then F have a maximum the electron label have a can have 14 high. So the block have a first row, second row, third row transition series have a there will be 10 elements. 10 elements have a series among the F block have a sumagi 4F have a 5F have a lady besar. So it will consist of 14 elements lagani have. Nareko. Aduedi Aina D block have a 10 elements and 4SC. This F electrons have a 14 electrons lebagi F series or F block elements have a 14 elements lakani. Kangadra. Kangani ko sida. Okay. Previous slide yung ko tada. So now, sige matuin na kaya transition elements hay si kay gino habang matamda d orbital duda ko b orbital duda incompletely fill hay ba that means ahang makhare yawi ha ba d orbital da yara ba ahang makhare yawo duna maram oraga makoi shibu transition state ni ahong banai bani na habu bane ba yare ko hong banai bani habne ba Then here, D block elements in transition elements hana sukawi aduga F block elements in sibuna inner transition elements hana kautani have. So from this brief introduction, we came to know that D block elements in sibuna transition elements hana kawi F block elements have a sibuna koina inner transition elements hana kawi have a Now let's go to another slide. Silo agra matung do classification sil asiko ako ina hoji high gi mama tamda kai high gra D block have series myam tungan legani and we are going to study in more details about the first row transition series to katane na high ko. Now here in this classification I'm showing you some transition series ki series tane so tawri ko. So here classification of the D block and F block elements study tawo matam se da D block ki transition series se mari thona legani ba. The first transition series, second transition series, third and fourth one. First transition series is 3D series high because 3D series have say in the previous slide I will show you again. Here akoina D have orbital se kanadagi hawe munna yengo matamda kanadagi hawe yengsi ba 3 dagi hawda. That means akoigi periods se kya lo there are 8 periods hydra. There are let's see 8 periods legani 18 groups legani haina tamgre ba ko aduna sigi period ki masing dune ba khona of principal da 8s hargalu shedido gan tabra aduna sida 8 loigrabani na 18 groups have sida khaidora ku matam sida kai hain khaido S block P block D block F block na khaido ine ba taraba so sida khaido ise ahan bagi series la ku matam da 1s S orbital khatang lai tra 1 is the there then 2 have a time sida su 2s and 2p si khatang lai ko again 3s 3p and 3d haraka uja sida 3d they have the first row of the transition series is known as 3d series however so here aduna never sida show to matam sida kai hariba first transition series hai kai hena khangeba 3D series and a kangne haise. Kanadagi hawi from scandium 21 atomic number to zinc powder video ba. That so my to na 3D lagi next 4D lai 5D and 6D and so my lagta laki ko ay ni iba matam da so chamana na iram gani you can see here 6D yawi ko 3D 4D 5D and 6D yawi ko so my to na transition series have sida magi first row second row third row and fourth row na tungan legani first row of transition series will be known as the 3D series next na 4D series 5D series na tungan lakani haba so let's see here 4D series na kanadagi hawgani yttrium thagina cadmium hawa chakani ba then transition series na lanthanum thagina mercury Hg mercury bauchit ko then again this fourth transition series 60 series na kanadagi actinium dagina actinium dagina organism bauchakani ba now again here lanthanide series lako madanda or 4F series have madanda lanthanoids ko gani hagre ba aduna ko ni F block elements inner transition elements and inner matanda series ani lakani amanda lanthanoids natragana lanthanides ꯑꯇꯣꯞꯄ ꯑꯃꯅ actinoids ꯅꯠꯇ꯭ꯔꯒꯅ actinides ꯅ ꯀꯧꯔꯛꯀꯅꯤ ꯍꯥꯏꯕ ꯌꯥꯔꯅꯤꯀꯣ okay next ꯑꯗꯨ ꯑꯣꯏꯔꯒꯗꯤ ꯍꯧꯖꯤꯛꯀꯤ ꯃꯌꯥꯝꯁꯤꯗ ꯑꯩꯈꯣꯏꯅ ꯀꯩ ꯍꯥꯏꯅ ꯅꯩꯅꯈ꯭ꯔꯦ 3D series 4D series 5D series ꯍꯥꯏꯅ ꯅꯩꯅꯈ꯭ꯔꯦꯕꯀꯣ ꯁꯤ ꯅꯩꯅꯕ ꯃꯇꯝꯁꯤꯗ ꯃꯃꯥꯡꯒꯤ ꯁ꯭ꯂꯥꯏꯗꯇꯣ ꯍꯥꯏꯐꯦꯠꯇꯪ ꯌꯦꯡꯒꯦꯁꯤꯀꯣ ꯑꯔꯣꯏꯕꯁꯤ ꯌꯦꯡꯉꯣ 3D series ꯀꯤ ꯑꯔꯣꯏꯕꯁꯤ zinc ꯑꯣꯏꯀꯣ 4D series ꯀꯤꯅ cadmium Cꯗ mercury ꯅ ꯑꯣꯏꯗ꯭ꯔꯥ ꯑꯗꯨ ꯑꯣꯏꯇꯥꯔꯒꯗꯤ ꯁꯨꯃꯥꯏꯅ ꯂꯩꯔꯤꯕ elements-ꯁꯤꯡꯁꯦ fulfill ꯑꯣꯏꯒꯅꯤ ꯍꯥꯏꯕ ꯃꯈꯣꯏꯒꯤꯗꯤ transition series ꯍꯥꯏꯕꯁꯤꯗ ꯑꯩꯅ ꯀꯩ ꯍꯥꯏꯈ꯭ꯔꯦ ꯍꯧꯖꯤꯛ ꯃꯃꯥꯡꯗ D ꯍꯥꯏꯕꯁꯤꯗ 10 ꯑꯅ ꯂꯩꯗꯣꯏꯕ ꯄꯣꯠꯁꯤꯅ maximum number of electrons ꯅ ꯍꯥꯏꯗ꯭ꯔꯥ D series hana lakpa matamsida D block elements ki series khudingmaksida number of elements kya oini hai 10 elements oini haigreba ko 10 elements oini haigreba na hoji kai haino sija scandium sigina jingbaw lakpa matamsida it will be always tara hapani ba yare ko 21 22 dagina lakpa matam 30 ba lakpa se kaino it is tara 10 ne ba ko adna 10 oini na kadawi they will have D10 electrons like ni haba aduna maram oiragane sigi not se laise yengasi ko here all the elements in the D block elements are all transition elements except kana high group 12 those present in a group 12 group 12 se yaw se kana lo asai gi zinc mercury cadmium hariba kangu se kana ide yawduba group number 12 te yawgani yare ko so here elements kana zinc ne cadmium ne mercury ne mokoi singje kai raweba D block element yaujaraga su kai haba mokoi singje transition elements kaudeba karigino because they have completely filled D orbital completely filled electron yawa that means D10 electron haisi yare ko so yarba D10 electron se completely fill oirabanina mokoi singsi koina transition elements ni hana logdi ha yare ko that means n-1 D orbital da 10 electron ya ns2 leba singsi koina transition elements hana logba ya de ha okay now here these elements differs in many characteristics kai do yam manade even mercury di kai high liquid at room temperature how high neba character do kai am khenaramani any types of the metals could kai high it will have hardness properties of hardness ni have neba adu mercury di kai dora it is liquid at room temperature high neba khena radu tare characteristic nam khena as well as rest of the other elements ma'am se yengna matamsu makhoi masin gi marakta phawde khenai haba yare ko aduna maram oiraga this zinc cadmium and mercury are not classified as transition series though they belongs to the transition series hapchai have one ni maming tagini haba yare ko okay let's go to the next slide then so electronic configuration the last electronic configuration first we are going to study the ngasagi D block elements singo hana study tawra matung na khoi F block da mung laksi ko F block ina tungana laksi so first we are going to study about the D block elements hana study taw thawasi call that so here electronic configuration sa kanagi no khoi ne do sha D block ki ka we are going to study about the D block in another set. So here, general electronic configuration. You are going to study two types of the electronic configuration. Badana general electronic configuration atau elements ki electronic configuration. Okay, I will tell you three types. Three types hai sipa. Amana ground, amana excited or stable. Aduga to pa amana general. So I will tell you here. Electronic configuration. See how we matamsida na makhan layeba karam kanaba hojiki general electronic configuration sima like re ko atopa amana stable electronic configuration adu last kana ground to halasi ko ground electronic configuration amana stable electronic configuration amana excited electronic configuration makhan ni ko habedi mi da su magi character tungan lebe du maina electronic configuration gi su makhan lai je yare ko tungan badi sida first high se electronic configuration high ra matung da general electronic configuration hana live pot se general electronic configuration high robot se kai mali ham matamna akoina element hamase see for example let's say we are studying the unit number 4 of class 12 na cha class 12 habase generally have matamna science stream art stream higher sebuko there are various types of the subject mein ami alra adu tare so see science see arts high tare we don't know what subject they included but we know that it is the arts it is science malatra adu khak haibugo maneba electronic configuration hawa matamna yari ko adu general high tare this one is the class 12 science this one is class 12 arts haida adu mine high tare it is known as a general electronic configuration I never do yarba now ground electronic configuration high tare kai ha matamna port ama se lokhaledna for example student ama se lokhaleba student ama khakse ma sige maming se it is so unique for that element yare ko madugi student to gi maming se unique hoidone ba aduga element to gi number to se unique hoidone ba adu maina ma electronic configuration tongana leisabado adu koina ground electronic configuration hai ba yare ko next stable electronic configuration hai taragadi whenever the akoina stable electronic configuration hai taradina koina two types of the stable electronic configuration if first completely filled habama half filled habama yai ko completely filled habadu dadi fully filled oigradine adu half filled habadu gi configuration electrons lost to halaga natra electrons jump to halaga to biya adine ma yare ko sumai to dina electrons ma gi orbital to ki atop orbital da chunghan paragadi adda phanga eba stable state to aduna stable electronic configuration hagani ba yare ko next ai hojik chung thok chung sin tawba na pan ki ko aduda chung doriba electron do aduda sidagi sida chongre hana have ko cha this is known as the excited state that means lower energy da leramiba electron amana higher energy da la aga chung sin tawragadi that will be termed as the excited electronic configuration ni hana logani ba example law siko example da suma high in high let's say 3D10 NS1 natragana sila nawra resi sa atopa malars okay 3D9NS2 samala ba electron nama ko 3D9NS2 have madam se the NS2 hydra s orbital the always stand for S2 hydra ko sa for S2 have madam se the kai hai s orbital the maximum number of electrons will be 2 na cha ani degi hebdi ade ba maximum se 2 ne ba ko and 2 degi ni hebbe ade ba ni na mari 2 lere D9 hana hai 9 have ko se yamna thina stable oideba ko mase ekta ingau ngau na lebu june stable oidebi da ko aduna mamonda di amma khatang bira aga di asi am ngai ga na yam stable oini hena lebu june ba genta bra aduna mase completely feel so oidre for example let's say akoi na ma ki stable electronic configuration se phangna bu khana bu kana sumane le hase bu ko se ki the orbital se se ki na electrons 1 2 3 4 5 6 7 8 9 sumana leire electrons ko aduga sida 4s ki na 1 2 sumana ani leire yaradra sumana leiba pot se magi stable electronic configuration ki state se lagna bo hona matandri kamai lakani 1 2 3 4 5 6 7 8 9 10 10 leire sida electron am khak legani ha sumana le di kai lani se 3d 10 4s 1 shila ade it is known as the stable electronic configuration stable kaurani bu ko aduda stable have matam sida yarmiba electron ani sidagi amadi kanada transfer to home transfer to dra sumaina sida leramba electron ama home transfer to agadi transfer to agadi ko kai haiba it is known as the excited electronic configuration ni have yana dra okay now adu regadi sidi ngasi ko general electronic configuration of the block elements kai orani n-1 d1 dagina 10 power electrons legani and s kina kaya legdiba 1 dagina 2 power legani ba sometimes zero also happens if there is a stable configuration lagna mo hana mo kande and s ta s orbital the zero chikibusu yawo ko adubu kayo diba generally magi lakko madanda 1 dagina 2 power di compulsory legale next n-1 stands for the inner d orbitals high let's see in the previous slide tom tangi gisiko so here see previous slide se yema tumna kai hai 1s ki manan 2s 2p 3s 3p next 3d se lakcha kana kana yawe 4s lakcha Like so sumai tawdana 4s means ns to never maning the lagba 3d means n minus 1 whole d gan tai ko sida ya iba mong je sida 1s leram hai 2s 2p 3s 3p lama tunda 4s laga 3d lagba ne ko aduna 3d have se kaino it is 4 minus 1 right that means n minus 1d and ns haido kaino 4s ko na lakta 4s lakpa na ns yari ko I think you might understand this one. So, sida dumani like ready n minus 1 stands for the inner d orbital. Then, atopam na kay which have 1 to 10 or electrons. 1 tagina 10 electrons pa yawani because it is a d orbital we can call maximum electrons kya ne ba 10 ba libiya bagi. Then, outermost na ns orbital ni adu mawon leke yaga da electrons na 1 tagina 2 ba. Yaraga. Then, it is a very little energy difference. Energy difference ka issue ka hera yana like there because it is one energy khatane makhada ama level perak ama khatan ka khalaga libni have dumai leyeba so energy difference yang pangna lete energy gap se between these two orbitals n minus 1 ka end orbital ani se khena debu ko kuch kahna half and completely filled sets of orbitals are relatively more stable hai sida so umka hai ko kana half filled habaga completely filled habaga set ani se sisna quite stable electronic configuration ni hai that means sida sumana pirasi ko okay 1 2 3 4 5 sumana orbital d orbital ni harasi ko sa d orbital label matam sina mari d orbital sing sigi maming sa dx minus dxy dyz dzx dx square minus y square dz square sumaya tunga leba mga se maming tunga leba like akogi yumda ka se chiginda living room sisina kitchen gi sisina bedroom sina bathroom washroom tunga letra sumaya leitana d gi su tunga na magi ka se gi maming leba yari ko so sumaya tawduna dxy dyz dzx dx square minus y square dz square sumaya legani ko sige lariba singsida electrons are distribute tawmatanda it is distributed uniformly sumane leramagadi it is known as half filled orbital sige half filled orbital say it is quite stable ko sige malaya atopa mana 1 2 3 4 5 6 7 8 9 10 Sina kay ko diba? It is 3D then. Or let's say it is only D. Kaya ko, D10, sina D5. D5 or matamdaga D10 or matamdaga it is quite stable have the short on the bait matuto ni ko. Sida kay hare D10 have matam sila electron tara. Chap chan like diba? Completely filled ka basin. Completely filled. Yari ko. So completely filled sina half filled. So completely filled ka half filled ka sina it is the most stable ni have. Yari ko. Then here do regadi sida hai nga sa hagi beda kay hai. Zinc haba, cadmium haba and mercury haba pot ahum se D orbital da 10 electrons yawa ba. Dun maram marga they are not considered as transition elements ni hena law di hai ba. So a consequence factor of this is that reflected in the electronic configuration of chromium and copper. Hari ko chromium and copper sida yengo matam sida magi electrons ka male 3d series 3d5 for s1 3d5 for s1 and atopa mana 3d10 for s1 ana lay have adudi completely fill amaga half fill amaga na cha 3d5 means half filled. 3D10 means completely filled. Completely filled and half filled. These are two the most stable electronic configuration. Example. Then here, it is due to the energy gap between the two sets of the orbitals 3d and 4s orbital. It is enough to prevent the electron entering d orbital. D orbital ga 4s orbital ga ani se habadi 3d ga 4s ga ani se ki energy difference is so small that it prevents d orbital the energy do or electron do chang kan athing ba piya ba yare ko. Okay, now let's go to another slide. So see that D series ki first D series to ko first transition row do gi the magi electronic configuration na. So let's see through this table se happening in minigi se ko yeng se do di kai haya scandium kanino 21 atomic number and 3d1 for s2 yare ko aduga sometimes here sedal lay to stable electronic configuration of chromium gi piraga lay ko and then manganese. Then copper gives the 29 obviously kai high 3d10 4s1 and the piraga lay ko. This is a stable electronic configuration. And now last one is the zinc. Kanadagi no scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc kana lagja. Sidal lakko mutam the zinc high report sigi magi electronic configuration se kai on 3d10 4s2. 3d10 4s2 orbina it is all completely filled. The orbital have a port the electron amma with a lemaga yaudeba natraga hanga yaudeba. See the decade away 3d10 4s1 have a say 4s2 the electron amma loksalaga tarakpaneba again here to the 3d4 4s2 have a say 1 amma loksalaga 3d5 tabaneba yako they are still kana transient elements but here jinky de kai oira jinky de raya aduna they are not considered as a transient elements haba. So mathang is na 4d series ko 4d series na yttrium dege kana bhavna lakto se cadmium bhavna hai ko yttrium na atomic number 39 adu ki chumna lakpaduna this one 48 bhava cadmium gi ko. So yttrium zirconium niobium molybdenum technetium ko ruthenium rhodium palladium silver adu matanga cadmium si bhavusina kanano 40 series 40 series wale ko 40 series wale ka magi stable electronic configuration still area sina electronic configuration cd ground electronic state dunya ba adu sina stable electronic state yare ko. Now again 5d series sina kana de hawe lanthanum degi na mercury bau chatkani yare ko. So lanthanum hari bajaga sidagi magi atomic number na 57 my electronic configuration na 5d16s2 yare ko. Then sidalai hafnium lanthanum ki mathang hafnium tantalum tungsten uranium degi osmium iridium platinum next gold gi you say orium hai bani ko gold then mercury ki atomic number na 80 yare ko 80 hore hadu mag stable electronic configuration som site be mercury ki dikhe dogi 5d10 6s2 completely filled hore ko no vacant electron yaudre natragana the orbital the hang siru umta yaudravne it is not considered as the transient elements. Next the last series kanano 6d series sida yaudre sida kana yung ko sida actinium dagina copernicium bhava yare ko. So in the previous slide ta ko sida actinium dagi organism bhava hai se this one should be copernicium bhava la oidu yare ko. Then again aduna copernicium bhava ani aduga magi atomic number na 112 yare ko. So si bhavu agani aduga magi electronic configuration na 6010 7s2 yare ba. So sumaya tawdina actinium rutherfordium dubrium seborgium ko adagi borium hafnium ko then meitnerium dumsterium uranium sehida hariba elements sigi da yariba elements se hanadi yaramde ko nauna puthorapa ngakni habuko aduna sehida yariba rutherfordium sometimes some 2 years back some 3 years back in hana puthoratiba dubrium then seborgium simana leriba sidagi seborgium degi na uranium haba then copernicium hause hojiti fulfill to araga 112 and organocin 118 fawulon phajna putho leiriba yani ko hanadi kaya khatano lermise 113 or 110 108 fawa adumaina mamin khase khanga lermane ba hojiti 118 fawa mamin phajana discover tawreba ko so here C was in 60 series here ko actinium ki atomic number sina 89 orega copernicium ki na 112 da smile legani so in the next class we are going to study about the position in a periodic table hypersimilar as well as magi metallic characters ka kadi no characters general properties na kai no trends na kai no ham to study tamnya se so till then bye bye